Today we're going to start section 1.6, Ordered Pairs and Relations. This should be a review for you from earlier this year as well as from previous math classes. The coordinate system is used to locate points. It is formed by the intersection of two number lines that meet at right angles at their 0 points. Those number lines are the y-axis, which runs vertically, and the x-axis, which runs horizontally. Recall that an ordered pair of numbers is used to locate any point on a coordinate plane. The first number is called the x-coordinate, and the second number is called the y-coordinate. In the example ordered pair 3, 2, 3 is the x-coordinate and corresponds to a number on the x-axis, and 2 is the y-coordinate and corresponds to a number on the y-axis. To graph an ordered pair, draw a dot at the point that corresponds to the ordered pair. The coordinates are your directions to locate the point. Let's look at example 1 to graph ordered pairs. The directions are to graph each ordered pair on a coordinate system. The first ordered pair is 4, 1. In order to graph 4, 1, we start at the origin, which you might recall as 0, 0. And since the x-coordinate is 4, we're going to move 4 units to the right. And with the y-coordinate of 1, we're going to move 1 unit up and draw a dot. In example B, the ordered pair 3, 0, we're going to start at the origin once again. The x-coordinate is 3, so we move 3 units to the right, and the y-coordinate is 0, so we will not move up. We'll draw a dot on the x-axis at 3, 0. Let's look at a couple together in guided practice 1. We'll graph each of these ordered pairs on a coordinate system. In example A, 0, 4, once again we start at the origin. And step 2 is we're going to move 0 units. So we're going to stay at the origin because the x-coordinate is 0. In step 3, we will move up 4 because the y-coordinate is positive 4. So we'll draw our dot at 0, 4. In example B, ordered pair 6, 7. Once again, we'll start at the origin and we'll move 6 units to the right because the x-coordinate is 6, positive 6. So we'll move 6 units to the right, and then we'll move 7 units up because the y-coordinate is positive 7. And we'll draw a dot where those two intersect at 6, 7. Now it's your turn to try. In self-check number 1, graph each ordered pair on a coordinate system. You will need a sheet of graph paper for this self-check. In example 2, we're going to identify ordered pairs. Again, this should be reviewed for you, but it's something we need to recall before we move on to graphing equations. Write the ordered pair that names each point. In example A, it asks us to write the ordered pair for point M. So we'll start at the origin and we'll move right on the x-axis until we find the x-coordinate. And that's at 6. So the x-coordinate of point M is 6. And then we'll move up until we find the y-coordinate. The y-coordinate is 3, so the ordered pair is 6, 3. Let's look at one together. In guided practice, we'll write the ordered pair that names each point. We're looking at point N. So step 1, we'll start at the origin. And we're going to move to the right until we find the x-coordinate. And the x-coordinate is going to be 9. And then we're going to move up until we find the y-coordinate. And here we're going to move up 0 because it doesn't move up off of the x-axis. So the ordered pair is 9, 0. Now it's your turn. In this self-practice, write the ordered pair that names each point, M and N. Next, we're going to look at relations. A relation is a set of ordered pairs. Relations have a domain, and the domain is the set of all x coordinates. It also has a range, which is the set of all y coordinates. In this example, the relation is 1, 3, 2, 4, 3, 5, 4, 6. The domain is going to be the x values, so 1, 2, 3, and 4. And notice we write them with brackets. And the range will be the y values, again written with brackets, 3, 4, 5, 6. Relations can be shown in several ways. We can show them with ordered pairs, 1, 3, 2, 4, 3, 4, 5, 6. We can show them with a table, in which case we're going to write the x coordinate first, 1, and the y coordinate second, 3, 2, 4, 3, 5, 4, 6. Or we can graph the ordered pairs and show the relation as a graph. In this case, it is a straight line. Let's look at example 3, relations as tables and graphs. It asks us to express the relation 4, 5, 5, 2, and 1, 6 as a table and a graph, then determine the domain and the range. It's put it into a table with 4, 5, and 1 under the x column and 5, 2, and 6 under the y column. When graphed, it's not a straight line this time, just 3 different points on the graph. The domain is the set of x values, so 4, 5, and 1, and the range is the set of y values, 5, 2, and 6. Let's look at guided practice 3 together. Let's express the relation 6, 8, 2, 9, and 0, 1 as a table and a graph, then determine the domain and the range. For the table, we'll just take the ordered pairs and we'll write the values in the proper place. For 6, 8, 6 is the x value and 8 is the y value. And then we have 2 and 9 and 0 and 1. Next, we'll graph them. So for 6, 8, we're going to go to the right 6 and up 8 and draw a point on our graph. And it's kind of hard for me to do with this stylus, so it's going to be a little messy. For 2, 9, we'll go to the right 2 and then up 9 and we'll draw a point on our graph. And for 0, 1, we'll start at the origin 0 and we won't move until we go up 1 and we'll draw our point. So we have 0, 1, 2, 9, and 6, 8. The domain of this relation is the set of x values, so 6, 2, and 0, and the range is the set of y values, 8, 9, and 1. Now it's your turn. In self-check 3, express the relation 2, 8, 5, 9, 0, 3 as a table and a graph. Then determine the domain and range. You will need a sheet of graph paper for this self-check. You will also need to make yourself a table on the back of your notes and put your domain and range on there as well. In example 4, we're going to apply relations. Applying relations is going to help us to get ready for functions in Chapter 8. Keeson is conducting a physics experiment. He drops a tennis ball from a height of 100 centimeters and then records the height after each bounce. The results are shown in the table. So at 0 bounces, he's at 100 centimeters. At 1 bounce, 50. At 2 bounces, 25. At 3 bounces, 13. At 4 bounces, 6. We need to write a relation for the data. This is just like a table, so we have an x and y value, and we're going to set those into ordered pairs. So we have 0, 100, 150, 225, 313, and 4, 6, and we've enclosed all of that in brackets. We'll graph the data, and notice that I have used each one of these points as 10. So 1 would actually be 10, and then 20, and then 30, and so on, instead of just ones, just to keep a smaller graph. So 0, 100 is going to be located at 0 and then up 100. 150 is going to be located at 1 and up 50. 225 is to the right 2 and up 25. 313 is to the right 3 and up 13. And 46 is to the right 4 and up 6. How high do you think the ball will bounce on the fifth bounce? Explain. Well, I think that it will bounce 3 centimeters because the height decreases by approximately 1/2 each time the ball bounces. So if you look, it goes 100 and then 50 and then 25 and then 13, which is about half of 25, and then 6, which is about half of 13. So on the fifth bounce, I think it would go to 3 centimeters. In guided practice 4, we're going to apply relations. The air pressure decreases as the distance from Earth increases. The table shows the air pressure for certain distances. At sea level, which is 0, the air pressure is 14.7. At 1 mile, it's 10.2. At 2 miles, it's 6.4. At 3 miles, it's 4.3. At 4 miles, it's 2.7. And at 5 miles, it's 1.6. So we'll write the relation using our brackets. We have 0, 14.7. 1, 10.2. Keep in mind it's difficult to write with the stylus, so I'm going to take up a lot of space here. 2, 6.4. 3, 4.3. 4, 2.7. And 5, 1.6. So it's a little bit messy, but I think you can figure it out. And then we're going to graph the data. Again, that's going to be very difficult with this stylus, but we'll give it a try. For 0, 14.7, we'll go to the right 0 and up 14.7, which is going to take us a little bit off of our actual graph. At 1, 10.2, just a little bit above our graph. At 2, 6.4, we're going to go just a little past the 6. At 3, 4.3. At 4, 2.7. At 5, 1.6. So if we're going to state the domain, it's going to be all of the x values, so 0, 1, 2, 3, 4, 5. And the range is going to be 14.7, 10.2, 6.4, 4.3, 2.7, and 1.6. In Self-Check 4, it's asking you to apply relations. It says that the average speed of a house mouse is 12 feet per second. It wants you to find the distance traveled at 3, 5, and 7 seconds and write the information in the table. So this time, instead of giving you the information, it's asking you to find it on your own. I've given you a little bit of a hint that you need to substitute the number of seconds in for 12 feet per second, which can be written as 12x, and then multiply. I did the first one for you. 12x equals 12 times 3 seconds, which equals 36. You need to complete the table for 5 and 7 seconds. Then you're going to write a relation for the data, graph the data, and state the domain and range of the relation.